basic armamentarium required is a well exposed lateral cephalogram, a compass, a sharp pencil, caliper, and an indelible marker. It is prudent to examine the radiograph for any projection errors. Ideally, advise the radiographer to give you at 100% a real projection and see whether the lateral borders of the mandible are superimposed correctly. The external auditory meatus also is single point, and the nasal bone and the orbits are not overlapping haphazardly, and the cervical vertebrae too is well exposed. Finally, check whether the occlusion is intact and you don't have open bite accidentally taken during exposure. Next step is to place the acetate tracing film over the lateral cephalogram. Stabilize it using abro tape. Do not use a cellophane tape because it leaves a resin marking over the film, and it's easy to remove with abro tape or masking tape. Post stabilization, the first step is to reorient the orientation marks over the acetate film and leave some identification marks. So therefore, when you are repositioning the film again post tracing, you will not make a superimposition error. The first step is to trace the soft tissue, starting from tracing the nose, the lip, and going smoothly over the chin and extend it as much possible over the nape of neck. The next step is to trace the lateral border of the orbits in a single sweep, and next the roof of the orbit. The point where these two line joins forms a supraorbital. Next step is to also trace the sella turcica, followed by which you will trace the superior wings of the sphenoid. You can trace the lateral condyle and the lateral border of the ramus, extending over the inferior border of the mandible and extending up to the chin and involving the mandibular central incisor. Trace all the way up to the apex of it and trace the maxillary central incisor too. Now we will be tracing the nasal bone, and this is the frontal sinus. The point N is a junction of the nasal bone to the frontal bone. Then we will be tracing the pterygomaxillary fissure, which helps us to locate the posterior border of the maxilla, that is the posterior nasal spine. The anterior most point on the maxilla is called as anterior nasal spine, that is ANS, and connecting these points we will be able to trace the maxilla, and that is connected to the central incisor. We can trace to some extent the occipital bone and the odontoid process of the vertebrae, the second vertebrae, and the third one. Using this, we'll be able to calculate the cervical vertebrae maturation index to know how much amount of skeletal growth potential is remaining. So this is a very important parameter when we are doing myofunctional therapy. Next, we can trace the maxillary first prominent molar and the deciduous second maxillary molar, followed by the same its counterparts in the mandibular arch, that is the first prominent molar mandible and the second deciduous primary molar. After this, you can remove the acetate film and have few photocopies of it, so that where you can do the measurement and angle measurements and linear measurements. So this any error can be easily replaced than rather doing it on the acetate filling. Taking the photocopies would be more prudent. Over the photocopied print of the tracing, we'll trace a supraorbital, that's a junction of the roof of the orbit and the lateral border of the orbit. Using the points anterior nasal spine and the posterior nasal spine, we'll be tracing the parietal plane. Sella inferior is the most inferior point of the sella turcica. Using the midpoints of the occlusal plane of the maxillary permanent and the second deciduous molar, will trace the functional occlusal plane. Now the line connecting the sella inferior, that is SI, and supraorbital forms the cranial plane, which is the most stablest part of the face, on whose reference other developing parts are compared. This is the cranial plane. Next is a parietal plane. It's a line connecting the point ANS and the PNS, that is antenasal spine and the posterior nasal spine. Using pterygomaxillary fissure, we'll be locating the posterior end of the parietal plane, that is the PNS. Now draw a line extending way behind the occipital bone. The functional occlusion plane connects the midpoints of the occlusal table of the first permanent molar and the second deciduous maxillary molar. The tangent running on the inferior border of the mandible is the mandibular plane. The point at which these four planes intersect is the most important point, and that's where we have to locate the point O. Now another tangent running on the lateral border of the ramus of the mandible, with the point where the mandibular plane and this line intersects, helps us to locate the constructed gonion. Now we'll be drawing to locate the exact center point in the way these four planes are intersecting. We'll draw two parallel lines. This is to locate the smallest vertical line connecting these four lines. That forms the center point, and the point dividing the smallest vertical line is the point O, from where we'll be constructing the arc. Using this point O and the next point being the supraorbital, we'll use a compass to trace the arc. That's the supraorbital, that's the point O. In one single sweep connecting these 2 points, we'll run an arc which runs over the midface, extending all the way up to the lower borders of the mandible, that is the chin. This arc helps us to know which part of the face is developing in which direction, and makes us to develop our treatment plan. Generally, the second arc we have to use is to develop the vertical at age 4. That is, for that we use the ANS and the nasion as a second point and run an arc over the pogonian region. That's the point at which the menton would be at age 4. From there, if you measure 10 mm and that second arc which we get is the vertical at which the menton would be at age 18. Now we know how far the menton lies in these two arcs. Let's just know how the chin is developing, that is the mandible is developing. So in this case, generally in normal limits, the ANS in the range of 2 mm from the arc, and the pogonion is also within the 1 mm range of the arc for ideal limits. And the menton grows at 0.75 mm per year. So if you calculate it to the year, you can know exactly how much it is from the vertical at age 4 and see whether the chin is growing in correct direction. The next is to use the constructed gonion and connect it to the point N, that is an ASION. Now what angle you get in these two zones is a way to measure whether the mandible is growing vertically or horizontally. The final result of Archial analysis is this picture. Here we'll be able to study how the face is developing in this case. Normally or ideally, the point ANS is within the 2 mm range from this arc. In this case, it is almost 5 mm behind, thus confirming that this is a case of retrusive maxilla. The second evidence is the maxillary central incisor to palatal plane angle is too steep, and that's a classical hallmark of a retruded maxilla. Now if you observe the pogonion and its distance from the arc is more or less in the 1 to 2 mm, that means the mandible is growing in proportion. At least the anterior development is within the normal limits. And if you measure even the distance from the vertical at age 4, you will see the chin is developing normally. So this is a case where it is a maxillary retrusion with normal developing mandible. It's also confirmed by the lower central incisor mandibular plane angle is approximately 90 degrees in the case. You can measure and see it will be the same. Thereby we confirm in this case it is a typical case where there is a underdeveloping midface with a normal developing mandible. So using this primary data, we can now plan ahead our next treatment of line, primarily focusing on the maxilla more and the soft tissue dysfunction, in particular using the dedicated appliance and the oromyofunctional therapy.